counting these lights. I took my jacket off. Okay, you're going on a trip. You're going to a business conference or something. Do you fill up with gas the night before, or do you do it in the morning? And it's just, what do? Do you fill up the night before, or do you do it in the morning?
Night before.
Night before.
What are you going to get coffee in the morning? Maybe you're going to stop and get coffee so you're still going to be there so you can stop. It's your choice. Maybe you're rushed for time. So you know you have to fill up the night before. Maybe you're going to leave at 4 in the morning. All these questions have to be answered. And you don't think about them when you decide what you're going to do. It runs through your mind, but you don't put it out on paper. That's what game theory is all about. Game theory, and nothing to do with games, it has to do with working things out, comparing, making a plan. Now I'm going to do 51 hours of lecture in 7 minutes. So listen up. Yeah, who's taking a college course and it's hard? They don't give you the answer until 6 weeks in. Why'd you tell me that when I started the course? I would have figured it out. So I'm going to start with the hardest thing about game theory. It's called Nash equilibrium. Have you ever taken a course on game theory, which is used in political science, used in economics, it's used in mathematics, it's used all across the spectrum for making decisions. Nash equilibrium simply means you pick the best choice for you to maximize your profit, not to win the whole game, to maximize your profit. I'll give you an example. Coke and Pepsi. Whoever thinks about Coke and Pepsi? Nobody, except me. What is the goal of Coke? Is it to put Pepsi out of business? No, it's to sell 1% more than Pepsi. It's to get more than 50% of the market. Although Coke actually has a greater market share, Pepsi makes more money. That is why when you go to Publix, every other week Coke is on sale and every week Pepsi's on sale. They have made the decision not to put each other out of business, but to work together. So they have signed a 26-week contract. Pepsi over here, Coke over here, they pay the same money. The Publix or every other store. That's how game theory works. Now, if you wanted to put Pepsi out of business and you were Coke, you'd realize it would put you out of business. Because Pepsi would lower the price to fight you, and then you lower it, and everyone would lose. That's how game theory works. Who plays the game rock, paper, scissors? Anyone familiar with it? Okay, 1, 2, 3, shoot. You play that game? Hey, who's played the game? Raise your hand. Okay, Robert, you never played rock, paper, scissors? Oh my gosh. Okay. In rock, paper, scissors, game you play 1, 2, 3, shoot, and you pick rock, paper, or scissors. Paper beats rock, scissors beats paper, and rock beats scissors. It's equal. It doesn't matter which one you pick. So I'm going to ask everyone to think of a choice. We're going to play rock, paper, scissors, and we're going to play it in our minds, and then we're going to, ready? Everybody think. 1, 2, 3, think. Okay, who's going to rock? Okay, who's going to paper? And who's going to scissors? Okay, great, you all lost. In game theory, there's theoretical game theory, and then there's the real world. In theoretical game theory, all your options are equal. You have a 33% chance to win with each one of the choices, and a 33% chance to tie, so it wouldn't make a difference. But in the real world, rock is the #1 answer. So everyone who picks scissors would lose more percentage of the time. You would work this into your equation, and this is how game theory works. And it's important to look at all your options, even if they're far-fetched, when you decide how you're going to approach a problem. Now, who's read Stephen Covey? Okay. Stephen Covey has something called synergy, or you've read some other people who have what's called a win-win proposition. Yes? Okay. In these options, or these proposals, you want to get the one that's going to give you the best opportunity based against a real economic opponent. If I'm fighting for market share with Michael, we're going to want to win-win. We both want to maximize our profit. Who's gotten a divorce? Richard, thank you. If you, I just thought that. Sorry about that. If you were in a divorce, you have two choices. You can go to the lawyer, or you can work it out amongst yourself. And when you go to the lawyer, who wins? The lawyer. So in game theory, you have to decide how you want to work things out. It's just a thinking process. We're going to do one more game. And we're going to use Nash equilibrium. Nash equilibrium means you pick the best possible choice so that you can win and maximize your profit. So I've got some numbers here, numbers 1 through 5. We're not going to write any numbers down yet. Here's the contest. You're going to pick one of these numbers. Everyone's going to pick a number. Don't write it down. We'll write it down in a minute. And the contest is the person who picks the number that is the average of the group, when we add it all up, without going over, wins the prize. Okay? You pick one of these numbers, and it's the average of the group without going over, you win the prize. That's easy. So can anybody think of a number that might work?
1.
Great. Wrong. Okay. So let's assume that using the analysis form, you take the first number 5. You say, well, if everybody picks 5, and I pick 4, I won't go over, because I will skew the results to be less than 5. I'll knock everybody else out, so I won't go over. So I'll pick 4. So right away you put an extra 5. Now put an extra 5, but you're not going to pick 5. And then you say, you know, all these people here are as smart as I am. And they're probably thinking the same way I am. And they're probably going to pick 4, so I better pick 3. And you can say, we not. So if you use Nash equilibrium to work out all your possibilities, the number to pick is number 1. Because that will always be the winning number when you're working with a group of people competing and trying to accomplish the same goal. Have I lost anybody yet?
Yeah.
Thank you. Have I lost you a little bit? Okay, as you work through each of these possibilities, it goes 5, 4, 3, 2, 1. You decide which is your best answer. It will always be, go to the end, it'll always be number 1 in this situation, because you'll say, these people all thought 4 and I'm going to think 3. And you say, you know, really they are smart to me. They're all going to think 3, so I'm going to think 2. And then finally you say, you know what, they'll think 2, I'm going to beat them, I'll think 1.
Richard and I both just picked 3.
I know, but that was out of thin air without thinking. But once you use game theory and apply this to each number, it works.
You had a proposition that probably we would get.
Right. So at the beginning, I just said a number. But once you analyze this, and you analyze the rock, paper, scissors problem, in fact, in the real world, the rock, paper, scissors was sent out as a contract between 2 bidders. There was 2 equal bidders, and they sent this to this ad agency and that ad agency, and they said, send back your answer to rock, paper, scissors. And this ad agency picked rock. And this ad agency did an analysis of it, picked paper. Because since they knew rock was the number 1 answer, they said more likely that this company will pick rock, will win, will pick paper. And they won the contract. So, how is this going to help your acumen? How is it going to help you in the real world? And I didn't use any real mathematics here. I want you to be aware that game theory is not mathematics. It's analysis thinking. When you go out to do something, you might not write down all the answers or all the possibilities, but you should systematically go through every possibility in every situation to decide the best answer. Getting back to our opening, who gets gas the night before they go on a trip? Sometimes you do, sometimes you don't, but really you've thought of all those processes. And that's what I want you to think about next time you do something. Think, what are all the possibilities and how can I plan ahead to maximize my outcome with game theory? And you don't get a diploma for this.
Let's hear it.